So to get to the basics is that we've just to recap quickly, since the stream dropped for a couple of people, is that the light in the scene, or the light in a pixel, is coming from these 4 primary sources. The first is ambient lighting, which we're just discussing quickly in the lighting window. Under the environment lighting, the source. So the value, I've got all the other lights in the scene switched off, so these panels are being lit entirely from the environmental lighting source. So this is the first layer of lighting in your scene. This is the bare minimum. Because the source is so bright, in this case, this means there cannot be any true blacks on white surfaces. So a white surface in here cannot go to black because the environmental lighting sets the bare minimum. Now, if you look at other virtual worlds in the past, they tend to have fairly high environmental lighting, so that you can always sort of perceive the difference between dark and sort of black objects. The difference between those, there is a difference. You can't ever make something purely black or dark. In space, you've got control over the full environmental lighting setup. So if we go down to here, I've got no other lights in the scene. If I go down to there, to black, we actually now have a completely black object, minus a couple of bits which are coming in from some reflection probes, which we'll get in a second. So as you can see, you can actually now make a very dark... Actually, it's coming from the skybox here. So we've set that off. There we go. So we've got no environmental reflections, no lighting. We've actually got black, even though those objects are white. So as if we set the the ambient lighting color up, now we've got sort of just flat lighting. So this is ambient lighting at 1, which means basically nothing can get get darker than the color that it's actually put at. No matter what is in the scene, this will always be whitish. And that's because the light has come from the ambient source, and the ambient source is set to white. Usually you would never want to do this. There is very few cases where you'd want to do this. The biggest one is if you're doing cartoon scenes, or scenes where you've got the need for very bright colours that can never descend into darkness. You can always see full detail. Pretty much cartoons and stylistic themes are the only times you actually ever use the source colour to be white. Normally you'd want it to be sort of a blend of things. So in here we've got, let's pull this back to the sky colour on this one. So normally you want the ambient lighting to be fairly dark. In fact, this probably is maybe a fraction too bright, but when we get back to avatars, you'll see that actually brightening the ambient isn't necessarily a bad thing. So if we've got a dark source here, so this is the first layer of our lighting. The next layer of our lighting comes from actually lights themselves. So if we go and create a new directional light in this scene, which is what I'm going to do, this means we now have a persistent and permanent light source that's just beaming rays directly into the scene that are all parallel to each other, and that's probably a point we'll get to when we come down to baked lighting, is the difference between having parallel lines of light and not. But for directional light, it's basically presumed that there is an infinitely sized light that is hovering somewhere infinitely away from the scene and sending unlimited light down into the scene. Now, the directional light, you usually have one major directional light in your scene, and that major directional scene light is usually the sun or some other bright object where you want sort of light and shadows to be cast from. So if we pull this this avatar in, you can see that obviously we've got a dark bit and a bright bit. So on back here with the dark bit, that dark bit is being lit primarily by the ambient source. There is some backlighting in here because we've got real-time global illumination ticked on, so I'll just tick that back off. So now you can see that the ambient source on the back here is from this, and maybe that's not a great. Hang on, just set this material up. It's not already. Oh, it's coming from the reflection probe there. So let me move this guy out. Maybe I'll use it. Here we go. Okay, so now we've got this guy should be, the ambient source should be coming from there. Why are you not? This is the demos. Oh, it's because that's going to be in the blues. No? Sorry guys, 1 second. I'm just going to pull in this guy into a new scene. This might be easier for demoing this because there is other stuff in that scene that is going to interfere here. So I'll just pull this back in. Okay, so now we've got you and we'll set the ambient light to nothing. So we've got a directional light in this scene that's casting a kind of yellowish source, which you can see, and then where it's not lit by the light, it's coming in from the ambient. So around here we've got the ambient plus the directional light. Around here we've got only the ambient. So I'm going to pull him back down and then move on. So your lights, generally speaking, your directional ambient, you want a couple of things about it. First is that usually you want it as a shadow caster. Usually you don't want to have more than 1 or 2 shadow casters in the scene. You can get away with a couple. Directional lights are the cheapest shadow casters, depending on how they're set up. They are a quite cheap equation to do, but the other ones, spotlights and things, aren't terrible. But usually if you've got two or three main directional lights in your scene, if you're casting shadows off them, it's not the end of the world. But usually you only have one directional light casting shadows, and then you might have something called a reflex light, which I'll get to in a second, but I want to cover off all these pixel lighting sources first. The next phase of lighting that comes in is our pre-baked lighting setups. I'm just going to pull you off as well. So our pre-baked lighting comes in two sources. The first is reflections. Now reflections are actually 2 passes again, so this is sort of 2 things in one. The first is it's got the environmental reflections. Now the environmental reflections is basically your skybox. So if I create an object in here that's a sphere, and then I make a new material, this material is going to be quite reflective. So this reflective material, I'll just swap that into there. And then we can set the metallic up to high and the smoothness quite high. Now smoothness we'll come into in a second when I get to PBR stuff, but basically you can see here this is reflecting from something, and what it's reflecting is here in the lighting window, the skybox. If I switch that off, you'll see that suddenly it's no longer reflecting anything. Now there is 2 sources of reflections, as I mentioned. The second source is what we call reflection probes. Now in space, again, there's 2 things. We've got both real-time reflections, and those are an option that you can toggle off and on in the viewer. That's under the settings to turn real-time reflections on and off. It's quite a heavy effect, so anyone who's on a really old computer, it probably doesn't want to be on. Also, some integrated graphics chips, again, it can be quite intensive, so you may want to consider switching it off. We switch it off automatically when we detect a low-power GPU. As well, so you can't rely on real-time reflections always being enabled when you're designing your scenes, but what you can rely on is baked reflections. And baked reflections are done through reflection probes. So if you go Game Object Light, you can see there's one up here under the menu called Reflection Probe. Now the reflection probe, as you can see here, it's box, and the box basically indicates the area that this reflection probe will have influence over. The second thing it has a source point, which is in this case a little sphere, and you can actually move and offset that source against the box by sort of using these box offset tools. There's a whole bunch of tools in here, so if I edit the projection bounds, I can actually change sort of the bounds of influence. I can change the position of the center. But the important part here is that when you place these reflection probes into your scene, it means that you can actually have reflections even though you don't have other sources, whether real-time or otherwise. Now, if you've got real-time reflections and reflection probes, they will work together. They won't conflict with each other. You'll get a better quality effect overall, where the baked reflections count for the things that are already in the scene at the time it was baked, and then the reflection probes were calculating for the things that were in there at the time. Sorry, the reflection probes will count the things that were in the scene at the time that the reflection probe was placed in the scene and the scene was uploaded. The real-time reflections will count on what's on the screen right now. So that means the real-time reflections will take advantage of things like avatars, cars, vehicles, things that people put in the scenes. But the baked reflections will take care of all the static geometry and things you've got in your scenes, your buildings, your land, your trees, all that kind of stuff can get put into the baked reflection probe, and that means they're not terribly expensive, and it also means they'll work on really low-end devices. Reflection probes we enable on pretty much everything. Even WebGL has support for reflection probes, although you can strip it out, and I probably do recommend stripping it from WebGL just because they can be quite expensive on a memory use aspect, and memory use in WebGL, if you're familiar, is a ongoing challenge. So I'm just going to save this scene as my initial lighting test scene, just so I can bake this and I can give you a demo. So I'm going to switch the environmental reflections off. So the environmental reflections are used when there's no reflection probe in that area of influence. If there's a reflection probe, then it'll use the reflection probe's data over the environmental data, and that's better if you're doing things with say you've got a indoor structure, or you've got a cave or something where you don't want the environmental reflections to leak in, then you want to place a reflection in there. So usually what I do is I place reflection probes in indoor environments, and those indoor environments work better when they've got the reflection probe because they're not reflecting things from outside. So you won't see sort of an outside landscape on your indoor environment if you've got a reflection probe that covers the indoor experience. You can place more than one reflection probe in an area. They will blend together based on the avatar's position, and they will update as objects move around the scene. So they won't update their reflections, but avatars and things will pick up the influence from the nearest reflection probe. So this is the third thing. I'm just going to bake this one. So I've saved this scene, and once you've done that, you can actually first things you need to is mark objects that are going to be reflected. They need to be reflection probe static. That means they'll be there when the probe is calculated. So I'm just going to mark all these objects as static. Yes, change children, and then from here I should be able to. You may need to have one of these on. Well, there we go. So we can hit bake reflection probes, and this is in the bottom of the generate lighting panel. So now when I select that reflection probe, you can actually see that the avatar and that little sphere are there and visible. So if I flip now, I know you can also see them here again on the object. So if I flip the environmental source off, makes no difference because this sphere is now calculating entirely from that reflection probe there. But if we get outside the bounds of influence, then suddenly it switches off. Now, normally what would happen is if we've got a skybox, it will flip on and off on that border. Now, you notice that's a bit of a sharp transition, and it's not really ideal. What you can do on the reflection probes, you can actually set a blend distance. Now, you need more than one reflection probe in the scene, and what you usually do is you set a priority, and the priority indicates which reflection probe is used when there's more than one. So that's actually the importance field. They've renamed that. So I'm just going to set this one to 100 because that means it's going to be the most super important one. And I'm going to set a second reflection probe in the scene that's got an importance of 1. I'm just going to bury this guy down here somewhere, and then I'm going to set the box size to 100. So this could cover your entire scene or more. So it can set to 1,000 if you like. It doesn't really make a difference. I'm just going to hit bake. So now I've got 2 reflection probes. One is not going to have a bunch of avatars. Well, they'll be up the top, but and one reflection probe, which is this one, has got the avatars next to it. So what I can do is, as I move out of here, notice what will happen. It'll blend quite smoothly between the two, and that's because on here there is a blend distance, which is oddly locked to 1 for some reason. Normally that's unlocked. I'm not 100% sure. That might be a new thing with Unity, but the key point is that basically as you move in and out of the reflection probe, the blending should work together pretty well. So that's the second aspect of how your pixels are lit. So reflection probes and real-time reflections are added on top of the other lighting. So the order goes, it starts with the ambient lighting, then it adds in light probes, then it adds in, which I'll get to light probes in a second, and then it adds in reflections and overall scene lighting. So all those 4 things are sort of added together, and then the resulting brightness is reflected on screen. So what Unity does is it actually calculates the color of every object in the scene, so it just does it completely flat, no lighting, and then finally it calculates the lighting that would affect each pixel, and then finally at the end it merges it all together with some additional calculations from the PBR stuff, which we'll get to in a second. So that sort of gives you an overview of how a pixel is lit. The final thing that's probably just worth noting is that there's gamma versus linear lighting. Now, there's 2 ways of calculating lighting, and this is in fact in the wrong settings. We should switch that off. When you do a space install editor settings, we'll actually switch the color space for you. So when you've got a computer monitor, the brightness of an individual pixel is actually multiplied to the power of 2.2. You don't really need to know too much about the details of this, but the basics is that there's 2 ways of calculating how lighting affects screens. One takes advantage of the fact that the screen's got its own sort of impacts. One does not. And as a result, you can get a different appearance. So as you see, I switched into linear. Linear is more accurate. It reflects real-world properties better, and it's the one we use in space. But you do have a choice. The old style, which is still used in a lot of old games and old virtual worlds, is gamma, and gamma, it's just a flat addition, so every bit of lighting adds to the previous, whereas in linear it's applied on a power curve, so it gets slightly more and slightly less at certain points in the lighting, and it actually means that shadows and things get a little bit more distinct than they would otherwise. But as you can see here, this is close to how it would actually look in world when we've got it in here, and actually the slight bit of orange of this light is actually creeping in quite a bit more in linear, whereas it's not so much in the in gamma, and that's because there's a little bit of a multiplicative effect. Alright, so that's the very basics of how your scenes are lit, but it doesn't really cover what makes an avatar look good. So I've actually got this avatar on screen. This is basically set up the way our avatars are almost. We've got include the avatars in the editor pack, and if you grab the skin pack that I released for the skin content creators, you can actually grab our latest skin shaders, but the impact of it will look kind of like this. Now if we look at this looks kind of garbage. Even as we rotate the lighting around, if we rotate this directional light around, you can see that this doesn't really look very good. This looks kind of like some of the other new virtual worlds that are out there. The avatar looks like clay, and it's not a good look. Now, our avatar skin shader does do a little bit more work on trying to minimize this sort of clayey, plasticky, not skin-looking effect by raising some of the ambient levels in our skin shader just a little bit. We use something that sort of emulates the effects of what's called subsurface scattering, and I won't go into that today, but at some point in the future we'll cover into how skin rendering is. But the short of it is that your scenes don't look very good if they have the Unity stock lighting, which is what we've got in this scene. Now the reason for that is that the ambient is too low and the directional light is too bright. So if I actually raise the ambient up here, suddenly this is looking a lot less bad, and that's because avatars need fairly high ambient. Now again, I told you that there's stylistic choices. If you're trying to build a cave or another dark structure, then your choice of ambient does matter. If you want to be able to get dark colors and dark environments, you need to have a high, you need to have a very dark ambient, and as a result, your avatars are not going to look very good. There is a couple of ways we can get around this. The first is to shift into blue. Your eyes naturally will push a little bit into blue when you've got darkness in here. So if we actually set this color like here, this could be used in a cave scene, but it still wouldn't look terrible. You can still see the avatar. It doesn't look plasticky, but you still got that perception of brightness. Now we can do a little bit more with tone mapping and things that we'll get to when we get to post. But the short answer is, if you're doing dark scenes, consider using a dark blue in your ambient lighting settings, because that means that you get the impact of the high contrast, but you don't get the nasty looking shadowing that can impact on your avatar. Second trick you can use light probes. Now light probes let you bounce light around a scene. So let's say I make a super quick, and hopefully this won't take terribly long to pre-calculate, otherwise I will have to move on, but I'm just going to grab a rock from my editor pack, and I'm just going to switch this over to the standard shader, and you know what, very smooth. Okay, so I've just got a rock here. Now say I'm making a cave, and I'm going to do that super quickly. And I'm going to move the avatar into here. This is my very ghetto cave, but it'll do the job. Okay, so now we've got the cave, and we can still see this is a bit too bright. This is not really doing the job. So I've just shrunk the avatar so we can fit the lighting effects. You can see that even in here, it's not really very dark, and part of that is the reflection probe. So I'm just going to nuke these two reflection probes, and it's still a bit new. Yeah. Let's grab this guy. Okay. So it's still quite bright. Now you can see this is not a bad solution. Going into blue actually still gives us the ability to impact that high contrast between outside and inside, but it's still not ideal. So what we can do is I'm just going to select all these rocks. I'm just going to mark them static. I'm going to show you one of the tools that comes with space. Now this is something we implemented specifically to get around these issues of light probe placement. So if we do put light probes in a scene, normally what you do is you grab a light probe group here in the game object light probe group, and basically this lets us sample static based lighting. Now static based lighting is computed offline, so what happens is the computer says I'm going to send thousands and thousands of probes into a scene, and those rays of light bounce around a couple of times. The computer pre-calculates all the possible combinations of how that would bounce around. So it means that light can come in from outside by bouncing off this ground, bouncing off the ceiling, bouncing on the floor, and so forth. I do see some questions in there. I will probably come back to those at the end because I'm already pressed for time, but I am happy to answer this stuff secondarily. So what the Unity Light Probe group does is it basically creates a bunch of these things. Now I can edit Light Probe, I can grab this one and I can move it around the scene, and basically you need to make a grid that kind of covers off where you've got points of contrast in the scene. So what I'd do is I'd normally, if I was doing this properly by hand, I would grab one of these, I'd duplicate, and I'd whoop. This is why I don't like this tool. God's sake, Unity. Normally I'd put one probe on the... This is not doing me wonders today. I'd put one in the shadow, one in the brightness, and basically you'd line them up in the border. So you'd put one there, and then hopefully, how are you behaving today? Let's grab this light probe group again and see if this is working. This is what happens when you run on beta versions of Unity. I don't suggest you do it if you can avoid it. So normally I'd be duplicating those, and I'd basically rim them along. So I'd probably put, for this kind of environment, I'd probably have like 6. So I'd have 1, 2, 3, 4, 5, 6, and then finally I'd put one on the inside just for good measure, because that would sample the light on the inside. And that way when you cross between them, it'll actually pick up your lighting automatically from the nearest probe. So if I look at this guy, this female avatar, and if I turn on... Well, actually I'll grab a game object. I'm just going to create a new cube. I'm just going to set a scale on this one to 0.1. If you do blend probes, it should actually... Oh, I need to bake this first before we'll actually see the light probe view, but you can actually see which light probes it's grabbing information from for calculating pre-calculated light. Now, to use this, we actually need to bake the scene. Now, the problem with Unity's light baking is it can take a while, so we're going to use the mixed global, and we're going to set to baked in direct. We'll cover these more in a minute. I'm just going to set these up. I'm going to set the light resolution to pretty low, and this should hopefully not take very long to calculate. Let's have a look. That was pretty quick. So now we should actually have baked lighting for all our indirect, and I don't know if that's coming in. Oh, I probably haven't set the directional light. Yep. Directional light needs to be static as well, and it also needs to be set from the mode to mixed or baked. I'll set this to mixed in this case. And we'll just go through this one more time. And now you can actually see we've actually got a much nicer lighting setup. Now this is a little bit balked because I got the values wrong, but we'll come down to that in a second. But you now can see that some of the light should have baked through, and if we've got these probes selected with the like, now you can actually see where it's sampling light from. So this object, if we make this bigger again, so let's do a set. You can actually see that it's picked up some of the light there, and then as we move this around, the lighting color is actually going to change. So it's going to get brighter on the outside, but it's darker on the inside. But it's still not going to that complete darkness ambient we had before. So if I make these two objects, put them next to each other, and I switch light probes off, you can see that that's how it looks just relying on the ambient. That's how it looks relying on the light probes. Now this also affects avatars. Avatars basically pick up from light probes, which means you can actually use baked lighting and get your avatars impacted by the results of that baked lighting. Now in Space, we, instead of placing all these bloody light probes by hand, we have a couple of nifty tools for you. And if you search for the word probe, you'll actually find a whole bunch of them. So in this case, if we go for probe, we've got one called Probe Navmesh. Now this guy is my favorite because it makes your time really easy. What we can do is we can calculate a navigation mesh, and we use this for you can use this, and we do recommend you bake one just because it means that we can hint things that need to move to you. So the upcoming pets feature, for example, relies on having navigation meshes baked so we can move the pets around and pathfind them to your avatar. What we're just going to quickly do is we're going to just click bake, and this is going to make a list of all the navigable zones in the region. Now this is unfortunately not going into our cave, so we'll just set that a bit lower, and I'm going to set the agent height to 1, and this way we're getting a bit more, but not quite enough. Just our avatar's a midget. There we go. Alright, so now we've got a path that sort of indicates which areas avatars can actually move around in. Now our probe Navmesh tool will actually use this information to place light probes automatically around your scene. So all you have to do is just click this update tick box, and you'll see it'll calculate a bunch of stuff. Now in this case the density is too low, so we've set the density to 25, which means it won't place a probe closer than 25 meters from another probe, which is not going to be good enough for here. So let's set this down to 2, so it'll place a whole bunch of them. And actually what you can see here is that it's gone and picked interesting points in the scene. So in this case it's picked the ceiling there, it's picked all this stuff. Now because this probe, this Navmesh doesn't have a lot of info, we might need to even set that down a bit lower. We'll just click the update button. I'm just going to take these levels off. So you can see here it's picked a couple of interesting points. Now when we bake the light probes, it should actually create a nice effective grid quickly that covers things. Now if you're actually building realistic structures, again, this is probably not great because my cave is not really to scale, but it will basically pick good settings for indoor and external environments, and it means that your lighting will contribute through nicely, and it means you don't need to place all these probes by hand. You still can. You can still go to your edit light probes and pick out a probe and say, alright, I'm going to move you guys down, I'm going to move you here, I'm going to add a new probe, we'll add a new probe there, and that probe moves here, etc, etc, etc. You can still do that by hand to clean up the automatic results, but the automatic results will at least give you some decent probe layouts to start with. Now, that probably covers the very basics of lighting your scene as far as sort of how the technical aspects work. And when you do things this way, it means your avatars won't look like garbage when you've got indoor and external environments, because it's bouncing some light from outside, and it'll keep things nice and smooth, and it'll actually diffuse the light evenly so you don't sort of have harsh shadows appearing on your avatar. So moving on to our second section, I really probably am going to end up breaking this up over 3 or 4 sessions, is PBR material maps. So we've covered sort of all these bits and pieces on lighting, but there's a whole bunch more we can talk about. So all these sort of discrete elements, the reflection probes, the ambient lighting, the directional lights, all those sorts of things can actually impact on your materials. And your materials are sort of your textures and all that stuff. We can actually use that information that we've got to actually blend the lighting on the materials in a far more interesting way. So what we're going to do is we're going to discuss a little bit about physically based rendering. Now we could go into some really complicated topics here, and certainly it's a topic that's not a waste of time to learn, but it's not something you need to learn. So as we had before, we had our little reflective material. Now what you may have noticed is that I have changed these 2 sliders here, the metallic and the smoothness sliders, when I was setting this up as a highly reflective object. By default, if both sliders are down at 0, you get this. And the reason why you get this versus when they're both at max and you get this is to do with physically based rendering. Now, physically based rendering means combining a whole bunch of facets of those elements I've discussed before. So in this case, the 2 sliders that you have generally under the standard shader, there's an alternative which is the specular setup, and I won't go into that today because that's not so commonly used. If you're using painting tools such as Substance Painter when working in space, those will actually generate additional texture maps for you that you can use to slot into these slots for Unity and get and import that stuff at the same time you're doing normal texturing. So if you're learning texturing for modern game development or anything like that, you probably have some familiarity with Substance Designer or Quixel Suite. They're both 2 tools that are basically, Quixel is a plugin for Photoshop, and Substance Painter is pretty much an alternative to Photoshop for painting 3D models. So both of those will output these extra maps, but I'm just going to give you a little bit of an intro into each of these slots that are available on the standard shader, what they do, and how they impact your rendering. The first is the albedo. Now the albedo is your basic texture. So in this particular case, I've got a rough object that looks like this, and it's a very low resolution texture, but that basically has the underlying color of the model. Now, in previous generations of games, engines, and virtual worlds, those textures are quite lit. So that means people have actually painted shadows onto the objects, they've painted highlights, they've done all that kind of stuff. When you're working with physically based materials, don't do that. You actually only need the basic rough color. You don't need to do anything special here. It really just can be a very flat color. So if I pull back up to the calibration scene, I'm going to save this scene here, and we'll come back to this one in a second, but come back to the calibration scene. This is one that Unity supplies that I mentioned before, and this actually probably has a good material map set up on it, I would hope. So on this pot label here, you can actually see this is what Unity uses for their thing. So as you can notice that even though there is some lighting and things applied to it, you can see down here, for instance, there's some shadowing. If you look on the actual texture map that Unity have made for this particular object, it doesn't exist. It's very flat. So when you're working with materials, you want those flat, because what we actually do is we bring the lighting in from the engine. The engine itself can calculate all those shadows and highlights and things, and it can do a better job because it can actually take into account the position of the camera, it can take into account the position of the light sources. You don't need to fake this stuff. There's no good reason to anymore. And we'll get into how you can pre-calculate to get some better results, but when we get down to the occlusion slot. But the next one I want to get to is the metallic and the smoothness slot. So these guys work in conjunction with each other, and they sort of describe the physical properties of the material. So objects have generally two physical properties as far as rendering is concerned. The first is it a metal? Now, this camera is rather blurred. I don't know if what's behaving in this one. I don't know why that's doing that. Okay, so we'll just look like this. So the first is metallic or not. Generally speaking, this runs ones in two positions. There's here, which is basically saying that it's not a metal, and it could be anywhere from 0 to sort of 0.1. Those are sort of the ranges for not metals. And then on the other end of the spectrum, you've got is metals, and usually they run from like 0.9 to 1. Everything in the middle you don't really use very often, because there's no actual physical objects that, well, there are very few physical objects that are metal or not metal. It's a binary decision usually, so this slider usually should be in one of the two positions. And as you see, when I drag between the two, the object goes from looking plastic to metal. And what you can see there is that the highlights on the object, so you can see when I've got here, they begin to pick up the color that's associated with the object, which is coming from the albedo slot. And the second thing is that the highlights tend to get a bit more concentrated. So you can see here that it's a bit of a difference there in what and how it reflects, but fairly obvious. And also it'll begin to pick up more, it'll begin to have lower brightness overall, but it'll be more concentrated in particular areas. So what you can see here is that this one, if you look over here in the rim, when it's a non-metallic object, it's still fairly flat. When it's a metallic object, it's fairly dark. It does tend to darken the object, but it also picks up more reflections. So it'll reflect more from the ambient sources or the reflection probes or anything like that. I'm just going to get these gizmos a little bit out of the way. There we go. The other property you have, and this is the more important of the two really, is the smoothness. Now, if you've ever looked at a mirror, it's very reflective, and the reason for that is that it is really smooth. That when two parallel photons aim on the mirror, they will both reflect back in parallel, and that's because the object is very smooth, and that means there's no sort of irregularities or bumps in the surface of the object. The more bumps and irregularities in the physical structure of the object, the more diffuse the way it renders. So in this case, you can see this looks this is not smooth, and you can see it looks like clay. So if you imagine clay, it's a whole bunch of tiny little holes. So when photons hit the clay, it bounces around all over the place through all the various holes that are in the clay, and as a result you get sort of like a diffuse warm reflected back, but you don't see particular highlights. Whereas as you get more and more smooth, the highlights get more concentrated and they get brighter. So as we begin to put post in here, you'll be able to see that even have impacts on effect on bloom and things as well. But one of the things to notice is the reflections on this object as I increase it. So here it's still reflecting objects. The light is being reflected, but it's because the object is irregular, they're getting bounced and smoothed out quite a lot. So the smoother the object, the more precise your reflections will be. There is one caveat I would add here: never go to 1.0 on your smoothness. If you go to 1.0, you get very weird looking bright speckles that appear all over the object, as the reflections are super concentrated into tiny little points. Generally speaking, sitting at no more than about 0.98 is a good idea. So you can still see that's quite reflective, but it means when I put a bright object next to this, so I put a point light right here, maybe that wasn't the best, set that to 1.5, as I put that in there. Don't know if we'll get those or not, but you can see it's quite bright, and the highlights begin to disappear as they get smaller and smaller, so they get sort of super bright, and when we've got bloom in place, they'll reflect badly. So just as a rule of thumb, don't ever set smoothness to 1, try keep it a little bit below 1, just for some sanity in your settings. The next map you're probably familiar with because it is available almost everywhere, and that is the normal map. Now the normal map, as you can see here, is just a bunch of, it's usually a weird purpley color with some red and some blue highlights on it. And basically the normal map stores information about how light should reflect off this position. So that actually stores a direction vector, which in non-technical terms is sort of just, it's an orientation of the surface. So if you want to put little bumps and things in there, you can use a normal map to do that, to create sort of highlights. And what happens is as the object, as light passes through it, the normal map will add a bit more detail into it. So you can see here that this particular object has a normal map, and as I increase the strength of it, you can see that it makes those ridges and things a bit more pronounced. Normal maps are something you should be considering using when you're modeling particularly characters, clothing, and that sort of thing, because they are high performance and let you get more polygons effectively into a model. Those polygons basically are free. So the texture map is a one-time cost that's paid when rendering your object, and that means there's just a fixed performance cost, but it means your normal map can theoretically help you simulate an object that's tens or hundreds of millions of polygons in total. So particularly with things like fabrics, where there's small, fine details, you can actually use a combination of a normal map and also a detail normal map, which we'll get to in a second. The next one is a height map. Now the height map, I don't have one handy here, but basically it does the same thing as the normal map, just in a much more complex way. I'll see if I've got a height map on here that'll actually have an impact on this object. This might be a fool's errand, but you can't really see that on here, but if you can see over here, very briefly, as I switch between none, you can sort of see there is a small difference there. The height map basically lets you calculate what's called parallax occlusion on the object. You probably don't need to mess with this one too much unless you know what you're doing, but if you are using something like Substance Painter to design your materials, then Substance Painter will give you a height map free. And the performance cost on small objects, the performance cost on this one is dependent on the size of the object on screen. So if it's a large object but it's in the distance, it's fine. If it's a small object but it's up close, it could be problematic. It depends on sort of the scale of things, but on most things like clothing and whatnot, including the height map is a good idea, because it gives you a whole bunch of extra detail, and it's okay for you to burn resources on an avatar detail. But I wouldn't go, for instance, adding a height map to every blade of grass in the scene, because the number of times it renders and things and how much of the scene it could occupy means that actually for the benefit you're getting, it may not be worth the performance cost. But usually speaking, in most modern graphics cards, it's not a problem, and we also do a good job of switching off these features on lower end graphics cards. So things like height maps can get potentially switched off, particularly on our mobile clients, which are going to come out at some point soon. Those ones, for instance, we switch those features off automatically. So having those things there, it's better to have them than to not, and to let us deal with the hassle of disabling those things, because we can do that inside the client. We don't need to you to optimize your content so much on that respect. The next one is occlusion. Now, as I said before, we had sort of this discussion of highlights and shadowing in your model. What you can do is you can bake ambient occlusioning, and now this can be done from your 3D renderer when you're doing the model design. Almost I think all of them have the ability to bake an occlusion map. including some of the texturing tools like Substance Painter, which I mentioned a second ago, has the ability to bake an occlusion map. And basically this just bakes small shadows in the scene. So what it actually does is, let me try and see if I can raise this one off. You can see actually this stuff, the occlusion along the rim, for example, is coming in, and this is actually being calculated in those maps and is included. And the benefit of not including it in the albedo like you did before, but including it in the material slot here, means that actually as we add a light, if we add a really bright light here on this rim, I'll just put it really close, you can see that actually it's not having any effect. The ambient occlusion is getting stripped off as the light is nearby. So you can make this really bright, but you can see that the ambient occlusion really only has an effect when there's no light on the area, and that means that your stuff looks better. That's the short of it. By having it separated, it means that we can only ambient occlusion only gets applied when you actually need it. The next slot is a detail mask. Now this comes down to the detail one, so I'll come back to that one. But the next one to come onto is emission. Now, if you've got an object that is emitting light or is otherwise super bright, so TV screens, that kind of stuff, I mean, it does emit light, you can use emission, and this can be used to make things glow too, through our post stack, and perhaps we'll come to that in a second when I get to post. Although I think I'm just about out of time, so I'll be quick. We use a lighting model, particularly with our post, because this is an important one. Any object that is brighter than white. So that means that on a sort of RGB scale, this goes 0 to 255 is the normal sort of color range when you're working in colors in 3D packages. We use high dynamic range rendering, which means that actually we go to values above 255. You can go up to very large values in the way we represent this stuff. Objects that are brighter than 255 will actually begin to bloom on the screen. That means they glow. So you can use the emission one to push things above that point. So you can see here that as I set the emission value, it does begin to glow out of there. So this is a physically based thing. It also means that things will glow if I put a really super bright light on them again. Spotlight again. And I'll set the intensity up to really high. You can see that that actually begins to glow off the area that is lit. So this background is a particularly useful exercise for calculating the glow, but you can actually see it particularly around here, that as it gets brighter than 1.0 it begins to emit light that sort of bleeds onto the camera, and that's only coming off that spotlight that we just added. So if we switch the spotlight off, the glow stops. But if you want to emulate that directly on an object, say if you've got a TV sign or neon or something like that, you just want to make it glow, use the emission field, just tick that on, and then you can make it glow whatever color you like. And that'll be added on top of the base lighting that we've already discussed. So this is actually added a fifth element that's added on top of the other 4 lighting elements that I've discussed already. Finally, the next one is the secondary maps. Now the secondary maps are extremely useful for high detail stuff. So as we get closer and closer to this model, you can see we're actually getting to pick up some pixels, because we are really close to the corner. Now this particular texture is not particularly great at showing that off, but maybe I can pull one up. And I'll come back with some more next week, but as you can see, we've sort of got a very pixelated texture. What you can do is you can actually combine it with a second texture. So in this case, if I go for another dirt texture, go here, you'll actually see that one, they multiply together. But what I can do on this one, I can set a higher tiling value than the base one. So here, I'm going to tile it 8 times. And now when we're up close, the details aren't so bad. Now this is only 8, you can go up to much higher. So let's say to 24. You can see that the detail map basically lets us have the original structural functions are there, but as you get closer, it doesn't really lose detail that much. So detail maps are extremely useful. You can use the same for normal maps. Again, if you're doing clothing, look at getting a bunch of detail normals for clothing, because they can let you get fabric patterns, fabric grooves, that kind of thing, and you can paint them on a repeating pattern. I've actually had some of our artists who have been building some of the stock content that we've got that for new avatars. I've had them upgrading our content to actually start using those new detail maps. You should see that in the next week or two, but hopefully that's sort of a useful exercise, and we covered off about half the stuff that I wanted to cover today. So next week we'll probably continue off the rest of it, and then we'll move on to something else for Artist Masterclass. Now I have my office hours now, so I'm just going to switch to chat in World. I'm happy to ask any questions and answer any questions that came up from today's session, but thank you all for attending, and I guess we'll do office hours now. I may as well keep them in the Welcome Center. I think everyone is logging in there as it is, so it's easy enough for us to get to. Cool. All right.